Welcome back to my YouTube channel because Civil Tech. I hope you guys doing well. So today in this video I am going to discuss about matrices topic which is mentioned in your syllabus of first semester of engineering mathematics 1 of Government Polytechnic College of Jharkhand, and the students who are in 12th standard also can watch this video because I am going to cover all the concept of matrices in this video. So now I'm going to start. The first topic of matrix is definition of matrix of order m into n and type of matrices with example. So the definition of matrix is a matrix is an ordered rectangular array of number or function. The number of functions are called as element and the entries of matrix. This is the symbol of matrix, and the number within rectangular array is known as element of matrix. And here there are two row 1 and 2 and two column. So the order of matrix is 2 into 2 because the order of matrix is equal to the multiplication of number of row and number of column. And here is also the same. The number of row is 2 and the number of column is 2. So the order of matrix is also 2 into 2, and the element within rectangular array can be any function such as trigonometric function, algebraic function, exponential function and real number. This is here I try to understand you. This is the row of matrix and it is the column of matrix, and you can also represent the matrix by Aij form where I represent the row number and J represent the column number. So this is the basic definition of matrix. Now we are going to discuss the types of matrices, and in this matrix this is the representation of order 3 into 3 matrix, and here A11, A12, A13, A21, A22, A23, A31, A32, A33 are the element of this matrix. A11 is the element at the place of row 1 and column 1. A12 at the place of row 1 and column 2, because I already discussed this is where I is the row numbers and J is the column number. So here is the 1 is row and 2 is the column number. So the element of this matrix A122 at the place of row 1 and column 2. Similarly A13, A21, A22, A23, A31, A32, A33 means A33 at the place where 3 rows and 3 column. So first type of matrix which we are going to discuss is the column matrix, and it is the representation of column matrix in which you can clearly see the column of matrix is 1 and the row of matrix, this matrix is more than 1, such as 1 2 3 4. So the condition for column matrix is the number of column must be 1 and the number of row can be more than 1. So for this matrix the number of row is 4 and number of column is 1. So the order of matrix is 4 into 1 because the order of matrix is equal to the multiplication of number of row and number of column, and also the number of element is also equal to the number of rows into number of column. So for this matrix the total number of element is 4 into 1 equal to 4, where m represent the number of row and n represent the number of column. Now the second type of matrix is row matrix. It represents the row matrix where the number of row is 1 and the number of column is 1 2 3 4. So similarly for the condition of row matrix the number of row must be 1 and the number of row can be more than 1. So for this matrix number of row is 1, number of column is 4. So order of this matrix is 1 into 4 and number of elements equal to 1 into 4 equal to 4. So the third type of matrix is horizontal and vertical matrix. So this is the representation of horizontal matrix where the number of row is 1 2 3 and the number of column is 1 2 3 4. Means in the horizontal matrix the number of row is less than the number of column, then the matrix will look like a horizontal. So this is the condition for horizontal matrix, कि the number of row less than number of column. And in the vertical matrix, this is the representation of vertical matrix where the number of row must be more than the number of column. In this matrix you can see the number of column is 1 and 2 and the number of row is 1 2 3 4 5. It means the number of row is 5 and the number of column is 2, so the matrix will look like vertical. This is the condition for horizontal and vertical matrix. And the fourth type of matrix is square matrix, and this is the only matrix which determinants exist. So in this matrix the condition for square matrix is number of row must be equal to the number of column. So here you can see the number of row is 1 2 3 and the number of column is 1 2 3. So the number of row is equal to the number of column, and a square matrix can be order of 2 into 2, 3 into 3, 4 into 4, 5 into 5, but the only condition is the number of row must be equal to the number of column. One more thing you have to understand in a square matrix is this is called principal diagonal, and these elements are known as principal diagonal element, and the above principal diagonal this matrix form is known as upper triangular matrix, and below the principal diagonal these elements form a matrix known as lower triangular matrix. So this is also type of matrix. And the next type of matrix is diagonal matrix. In the diagonal matrix you can clearly see there is only diagonal elements are here and the remaining elements are 0. So the upper triangular matrix elements are 0, lower triangular matrix are also 0, and only diagonal elements are here. So in the diagonal matrix the diagonal elements are present and all the remaining elements are 0. And the sixth type of matrix is a scalar matrix. In a scalar matrix you can see similarly there are also only the diagonal elements, but the condition for a scalar matrix is the diagonal elements must be same and all the remaining elements are 0, just like 1 2 3 sorry 1 1 1 2 2 2 3 3 3. But in the diagonal matrix it is 1 2 3. But in the case of a scalar matrix the diagonal elements must be same 1 1 1 2 2 2. So there is the only difference between diagonal matrix and scalar matrix. Now the seventh type of matrix is identity matrix, and in the identity matrix the diagonal elements must be 1 1 1 1 and all the remaining elements will be 0. So if the diagonal elements are 1 1 1 means same, so it is also called as a scalar matrix. And the last type of matrix is zero matrix or null matrix. So in this matrix you can see all the elements are 0, so it is called as zero matrix or null matrix. So this is the